Alright, so the normal distribution is a probability topic that occurs with some level of regularity on the IB exam. For that matter, it's pretty much a guaranteed topic, like you're going to see one of these questions. We're running short on time, and so what I'm going to do is in the next 3 videos, I'm going to give you an introduction to the normal distribution and an idea for sort of how to tackle probably 80% of the questions you're going to see on the exam. There's sort of that tough 20% that you might see, but the stuff I'm going to get you is at least going to give you the basics you need to get through the easy problems, right? So a couple of major points here. First of all, if a problem ever refers to a normal distribution or data that's normally distributed, it basically means you're looking at a normal distribution problem. Okay, so if you see normal distribution or normally distributed, you know you're going to have this kind of problem. As soon as you see that, like I don't care what the problem says, draw a bell curve. And that's what this video is about. It's about drawing the things. So draw a bell curve with like an x-axis along the bottom. Drawing that thing and labeling it properly is totally worth points on the exam. So if it's a 4 or 5 or 6 mark problem, you can easily pick up 1 or 2 points just by appropriately drawing the picture. When you draw that picture, like I said, I'm going to get to that in this video, the mean of the distribution should always be in the center of the curve, and personally I like to label the standard deviation somewhere above that. I don't have much space on this slide, but I'll sort of show you what I mean by that. If you sort of put an x-axis and then sort of draw a bell curve on top of it, I'll sort of draw a line here and say, cool, the mean, mu, is, if they say the mean is 50, great, you put a 50 there. The symbol for standard deviation is sigma, so I'll just put sigma equals 7 above it. Down here, I like to keep all of my data, like, if this is heights, then fine, this is the height being 50. I put this up on the top because it's not really anywhere along the x-axis, it's just pertinent data. Okay. As a note, all of the area underneath this entire curve is 1. And most questions are either going to ask you for the proportion of some event happening, or what the event is that leads to a particular probability. And like I said, I'm going to cover those 2 problems in 2 separate videos, so one for one and then one for the other. The 2 examples that I have here are really just about how to draw these curves and how to identify what you're looking for in the problems. So let's get to those examples. So here's the first one. The mass of toys being manufactured on a manufacturing line has a mean of 400 grams and a standard deviation of 15 grams. So as soon as we see that, like I mentioned this before, as soon as you see that, you sort of draw your bell curve. I always start from the middle because I feel like it helps me to draw a better bell curve. So there we go, there's my bell curve. And we can label some things. We're told that the mean is 400, so that means right here in the middle I have mu is 400. And we're told the standard deviation of the thing is 15. Okay, so before I even read question A, I draw that thing, because if that alone isn't worth 1 point, it's at least setting me up for getting that. So then question A actually says, draw a normal distribution curve and shade the section that would give a proportion of toys that have a mass between 395 and 415 grams. So for this, you sort of say, okay, well, if this down here really is an x-axis, then it goes from, negative infinity to positive infinity. And if this is where 400 is, then 395 is just somewhere to the left of that. And 415 is sort of, further to the right of that. Now somebody might ask, like, oh, how did I know to do 395 here instead of here or here? I didn't. I'm just estimating here. So now they want me to shade this thing, and that just means that, the section that I'm looking for is this. Now, the way that you actually compute that is going to be using the calculator, and I'm going to be talking about that in the next video. But something for you to think about is the area of this entire curve is 1. And so this section that I've drawn here, if I had to guess looking at this picture, I'd say, that looks like 60% of it. Well, cool, that means the proportion of those toys would be 0.6. If I was estimating using my diagram, that's what it would be. That's kind of the theory and the idea behind the normal distribution, is that if you draw the picture and shade the area, if we can find that area, that'll give us a proportion of that happening. Okay. In part B, the heaviest 10% of the toys are rejected due to excessive shipping costs. Indicate on the graph a maximum mass X for the toys to be accepted. Right, so same thing. I'm going to draw the normal curve for this. Right, you've got, you draw your bell curve. You put your 400 in the middle of it. This is, mu equals 400. You put your standard deviation of 15 on the top, and it says the top 10% of toys. So that means, up here somewhere, there is some value x. And what we know is that the area that's bigger than that is 0.1. Now, something that's going to be really important for us is knowing that, so therefore, what is the area less than that? Well, the area less than that has to be 0.9. It turns out that when we use our formulas for, not our formulas, when we use the calculator for this, it's always going to want to know what is the area to the left of the thing you're looking at. So if they say, oh yeah, 10% are above a certain mark, great. That means 90% are lower than that. And that 90% is the probability or the figure that we're looking for and that we'll work with. So again, in the next video we'll talk about how we compute this. Right now we're just talking about how to set them up. This example is incredibly similar to the last one. This is just about a kid playing outside of the monster truck instead of, toys on a production line. So pause the video, make sure that you can do this on your own, and, we'll check our answers. Okay, so the first thing we do is we draw the normal curve. Again, before I even read the question, I will generally draw a normal curve because I know it's going to matter, right? We know that the mean of this thing is 35, the standard deviation is 7. So draw the normal curve and shade the region that would represent a child playing for at least 45 minutes. So at least 45 minutes means more than 45 minutes. So it means there's some value up here, 45, and I am shading above that. And if I was actually solving this problem, I would want to know what that area was in order to figure out what the proportion of children was that played for more than 45 minutes with a monster truck outside. Part B, the top 7% of children are labeled as monster truck maniacs. Label on a normal curve the minimum amount of time x that must be spent to be considered a monster truck maniac. So same deal. I'm going to draw my normal curve with my x-axis. I put mu equals 35 in the middle of it. I put standard deviation 7 above it. The top 7%, so again, that means there's some value up here, x, where the area bigger than that is 0.07. And I mentioned before that the area that's less than that, all of this back here, is therefore 0.93. And that's going to matter when we actually go to doing computations for this. So hopefully the setup of these things makes sense. The next thing I'm going to do is talk about, in the next 2 videos, is talk about how we compute these things using the calculator. So you're going to want to have, your TI-84 calculator or, whatever calculator you use for it. So I'll see you there.